Now, another really important data type is that of strings. And we're still working for our Python certified entry-level programmer, and that's the exam 30-02, and we're currently on objective 1.3. The objective looks at all of our data types, but in this clip, we're specifically looking at strings. A string is either a single character or a string of multiple characters. To identify the data type, we can use double or single quotes in pairs. But whatever we use, we should be consistent throughout the script. So if we like double quotes, let's use double quotes throughout the script. If we like single quotes, then let's use single quotes. But let's try and avoid mixing and matching. For example, don't have in your script maybe the first few strings being double quotes and the last few strings being single quotes. We could also use triple quotes, but triple quotes, either triple double quotes or triple single quotes, are used to identify multi-line strings, where we can maintain the line return character within the string. We also have many methods with all of our objects. Python is an object-oriented language, which means that we have methods built into each of our objects. In strings, common methods could include lower, upper, and title to manipulate the case of our string. As we move into the demonstration, we're going to look at working with our strings. We'll look at the methods associated with our strings. We can look at string concatenation and something that seems a little bit strange at first, but is really useful, string multiplication. So make sure you stay around for that. Come on, let's go through and see if we can find our Jupyter notebook. Having dived our way all the way through our integers, our floats and our booleans, let's now spend a little bit of time looking at strings. And here we are. Welcome back to my glorious Jupyter notebook. A Jupyter notebook where we can start investigating our strings within Python. When we were dealing with our numeric objects, such as integers, we could just put the value itself. And here we can see then that we've put in an integer of 10. We just put in 10 and we get 10 out. Or if I try a string, maybe a string called Fred, and hit Shift and Enter, then I'm getting a name error exception. The name Fred is not defined. It's looking for maybe a variable or maybe a function, some object in Python named Fred. So if we wanted a string called Fred, then we go through and put our quotes around it. And we can use single quotes. Alternatively, we could use double quotes. It is our choice. But we're asked to be consistent. Otherwise, people are going to be thinking, why has Fred got single quotes and Smith got double quotes? They'll be thinking there's some special differentiation between Fred and Smith here. But there isn't. We can use single or double quotes. We could also combine strings together. So there's nothing stopping me having a string called Fred, and then a space, and then a string called Smith. This is really one string called Fred Smith. And we can see then that we get Fred Smith coming back. If we had two separate strings, we could then go through and have Fred, and then concatenate with the plus. So we could have Fred Smith. And when we take a look at this, we get Fred Smith coming back exactly as we put in. We never put in a space, so the concatenation did not put a space for us. These things are literals. So if we do need a space, we'll put a space in yourself. So a string, and we can concatenate that with the plus. So Fred plus a space plus Smith. There's also nothing stopping us creating a variable. So let's say we wanted Fred Smith as our name. We could create a name variable and assign it the value of Fred Smith. We can hit Shift and Enter, and of course now we've populated the name variable. When we go through and let's say print it out, and we can print it out just as the name, because that's now an object in Python, and we can see that we get Fred Smith. It also highlights that if we're getting input from users, the data might not be in a consistent format. So one of the nice things that we can do is, if I go back to print name, is start using some of the methods of the string class. So I could use then the upper method to convert that to uppercase. We also have a lower method, but of course there's no point using that as it was all stored in lowercase anyway. We have the title case, where the first character of each word is uppercased, and we have capitalized where the beginning character is uppercased. So we get Fred Smith with the uppercase F. So there's lots of things that we can do to format the input of strings and to make sure that we are dealing with the correct case. Ultimately, we haven't changed, though, the variable at all. So if I go back now and take a look at the name variable, it is still going to be in lowercase. At no stage did we reset the value of name. We can also have triple quotes to make things a little bit more complex. If we wanted to store the address, we could have the address being assigned the value, and I'm going to open up 3 quotes now. And we can go through and say 3 My Avenue. We're maintaining the line feed, and we can go through and put Stoke. We can specify that's in the UK, and then close off our triple quotes. We can use triple single quotes or triple double quotes. Shift and Enter. That now stores our variable, and when we go through and look at printing out the address variable, we can see then that we have the address stored. One last thing that we'll take a look at that can be really useful is working with the length of a string. Let's go back and take a look at our name variable. Here on line 12, we're printing the name. Well, let's print it back in title case. So, of course, we're getting the Fred Smith now in title case. But what if we wanted to highlight this a little bit, separate it from maybe other text that was following? We might want to use an underscore, or perhaps use our equal sign as an underscore. But how many equal signs do we need? Well, let's go through and see what we can do. If I go through then and print out my string being the equal sign, I want to use this as my underscore for my name. But the nice thing is I can use the multiplication. We saw that we could use the addition for concatenation. Multiplication is saying how many do we want. And the number we want is going to be the length of the name. So I can use the len function against the name variable. And that's going to show the number of characters that we have. And we can see now that we have Fred Smith highlighted with our equal sign working as our underscores. So this is working nicely. And of course, it's dynamically set based on the length of the name. If we change then our name from Joe Smith to Sally Sonderheim, and then as we go through and execute this, make sure that we store the name variable, but we can now see that we've got Sally Sonderheim, and we can see the underscores are correctly lengthed to the length of the new name. So this is really useful, and I know you're going to be able to use this.